Afternoon, everyone, all the faculties and the delegates, chairperson, sir. And at the outset, I would like to thank the organizing committee for giving me this opportunity of presenting these two abstracts. So for my first abstract, I would be focusing on a research article by the Stanford University, which is on optimizing efficiency and safety in EBRT using automated plan check, APC tool, and Six Sigma. Next slide, please. So what can all be automated in radiation oncology? So automation is a big new game in the field of radiation oncology. This is what we all know. The major share of international resources are now being diverted to studying and analyzing the effectiveness of optimizing various fields and aspects of radiation oncology. So, but for this research, the authors have focused on automation for QA, that is quality assurance and quality check. They have used an APC software, which is the automated plan check software, and Six Sigma workflow. Next, please. This is how the automated plan checker software developed in-house from Stanford University looks like. This is their interface. Next, please. So next, please. So this is the Six Sigma DMAIC. So DMAIC is an acronym which stands for Define, Measure, Analyze, Improve, and Control. It's an old strategy that has always been used to effectively increase the efficiency of a quality improvement project. So by define, they wanted to, it was aimed to describe the scope and goals of QI project and to lay out project timeline and identify involved staff. The measure stage was aimed to investigate the defects arising in treatment plans, learning system, the incident system, whereas the analyze stage was aimed to quantitatively investigate and establish highest risk check item using FMEA. Now, so FMEA stands for the default and analyzing the effect of those faults. The improved stage was aimed to develop and deploy an APC tool based on Pareto sorted text items. And the final control stage was... Sorry? Yeah, so the control stage was aimed to create a continuous feedback loop to provide a sustained optimization in performance monitoring design and implementation of each stage, as in the description. Next, please. And next slide, please. So can I have the entire slide first, please? Next, please. Yeah. So the goal of this stage, as I said earlier, was to define certain parameters. They needed to define goals and challenges that will encounter during this research. They also identified challenges and defined that successful development and the implementation of automated plan checking software, they rely on a collective repository of knowledge and comprehensive efforts from the multidisciplinary team. So these multidisciplinary teams, they often have challenges and complexities within different radiotherapy treatment techniques, modalities, and specific protocols. Next, please. So they also wanted to define a specific timeline. So this timeline was started from January 2018 and is still ongoing. Next, please. So this is the multidisciplinary team which was used in this research project, which included physicists, dosimetrists, physicians, and RTPs as per our daily clinical scenarios. Next, please. So for the measure stage, they had as identified the ILS, which is the incident learning system, are used for both reporting and learning by collecting patient safety related events, analyzing related clinical impacts, and extracting common errors from these ILS. So for this research, they used primarily two ILS reporting systems, the STAR and the Good Catch. Now, I just wanted to say something that this STAR and Good Catch is their in-house ILS, which is not something which has been standardized internationally. So STAR is a non-anonymous 22-item web form which is open to all the radiation oncology department there and is specifically for higher severity incidents. Whereas Good Catch is relatively is an anonymous 4-item web where you can report errors but anonymously. Next, please. So for the analyze stage, they use the FMEA, which is the effect monitoring system where you analyze the failure modes and the effect analysis accordingly. In this stage, the check items eligible for automations were identified, and then they were prioritized using the FMEA protocol. An itemized list of the individual physics plan check steps were compiled using the AAPM TG275 draft checklist. This is something we all know. Team ranks following the severity of the impact, the detectability dormancy as the probability of error going undetected, or the occurrence, which was the determined based on the records from the departmental ILS. So this is how they analyzed the data, and this data was then Pareto sorted. So what is Pareto sorted? The plan checking steps were sorted in the order of decreasing RPN. RPN stands for the risk priority number, so to determine the highest priority item to be addressed with this proposed analysis. Next, please. Next, please. Yeah. So now comes the improve stage. So they were planning to use all the data that they had and come to an improve stage. So what was this improve stage? Can I have the entire slide, please? Yeah. Thank you. The APC is specifically tailored to the departmental policy, their departmental policy and clinical workflow. So they had used this Sharp software and then collaborated with Eclipse API to form this Eclipse scripting API. So basically what they're trying to say is this scripting data, the software had used a lot of the data and then incorporated in the in-house running rating system, so that the dosimetrist and as well as the physicist can use those data in individual clinical assessments. Next, please.
Thank you.
So the control stage was aimed to provide a sustained optimization to the APC tool by creating a feedback loop. So what they now aimed was that whatever they have achieved, it should be in a feedback loop so that they could monitor and improve the robustness of the software. So the QI team conducted reviews and reported errors on a bi-monthly basis and then reported this control stage. Next, please. So this is the checklist, this exhaustive checklist. In fact, it consisted of about 101 check items in total, and it was Pareto sorted by RPN. And they wanted to identify the automation priority, and they had so far they had automated about 60% of these 101 check items. Next, please. Next, please. Yeah. So this was their result now. So what they wanted to say from this result was that the RPN ranking reevaluation 9 months post APC demonstrated a statistically significant average decrease in the RPN values. Now it was quite a sharp drop from 129.2 to 83.7%, which is statistically significant. So what they said was that the effectiveness of the APC tool is most evident in decreasing the high severity errors of prescriptions and plan mismatches and incorrect anti-center shift instructions to the therapist. So these three parameters came out to be the most effective ones, which could be checked with using these APC. Next, please. So as various quality improvement measures were implemented in the clinic to prevent errors in treatment planning, corrective actions taken to alert staff, they resulted in certain corrections. And what they found out was that the before plan approval, the first run versus final run, there was a sharp drop of 13.3 to 4.4%. So what does it mean? It means that they were preventing error propagation, which is, and this was statistically significant. Next, please. So what is efficiency study? So they used 20 clinical treatment plans. This is something which is not mentioned in the slide, but in their paper, they had 8 SBRTs and 6 BMS and 6 PDCRT plans, which were prospectively selected to participate in the efficiency study. So what they used was these plans were divided into two equal groups. One was for manual physics plan check and the other was for APC assisted plan check. What they picked up was 5 errors were found in 10 manually checked plans, including high severity errors of the prescription versus plan discrepancy and missing shift notes. In contrast, only 1 error propagated to physics plan check out of the 10 APC checked plans, showing an 80% decrease in error. So the average time gained with the APC assistance was about 10 plus minus 7 minutes, which is statistically significant. Next, please. So this was the plan documentation interface, which they subsequently uploaded to AryaTalk and automatically generated shift notes to the ROP. So basically what they're trying to say is that whatever their work that they had done, it was computerized and was automated. Next, please. So what have we learned till now? The ILS-driven data is a must. We need to quantify errors and prevent them from happening upstream. So basically they had departmental ILS, but you can also use what is called as radiation oncology ILS, which is their nationalized standardized system of incident learning system. Next, please. So, in regards to quality control and quality management, the robustness, what they found is the demise feedback loop was instrumental in getting their dosimetry support. So because of that exhaustive demise feedback loop, their entire result propagated into an effective output. Next, please. So, and then they actually said one of the most important things is that standardization. Their entire result is based on the fact that their software, their protocol, and their demise feedback loop was standardized. So by standardization, they could have a consistent procedure and policy, which could be consistently had a consistent nomenclature and definition as per the ASTRO white paper. Next, please. Yeah, this is the paper that they had used. So what else could you do with this scripting software? ESAPIX is an open source extension library for Variant Eclipse. So they had used Variant Eclipse scripting API. People who have different softwares can use different APIs. And so they were trying to use this software for easy data mining for different clinical trials as well. Something which was not a part of this study, but this is what they wanted to do in future. Next, please. So as per their conclusion, the authors concluded that Six Sigma demise methodology is useful and effective for clinical QI projects. Automation using SRP, which is the Eclipse software, improves quality and efficiency of treatment planning procedure, plan checking procedure, especially for high severity errors. Direct impact on patient safety is challenging to quantify. Reduced error frequency reported is in good catch, and reduced error propagation to treatment reported in STAR. Next, please. For the future work, they wanted to use these softwares and their protocol for highly error-prone PDI checks, including plan quality dosimetry constraint checks, creating a separate module for therapy plan checks, as well as brachytherapy plans, and APC to identify outliers based on population statistics for previously treated plans. So this is their integration of plan quality with the APC and their current clinical form. Thank you.